We should be able to calculate if we give more information, but here why not with the rocket deal starting from here, okay? So this is the principal axis. The principal axis basically working as the neutral axis. So now the point loading applied to here, so we have to decompose the point loading into the direction of the neutral axis. So here this is, let me decompose into that direction. So that would be, let me draw that one here. So that's the given P, so that will decompose into two directions. Okay, so this one is in the x prime direction, let me call it Vx prime. This one is y prime direction, let me call it Vy prime. Okay, so now for this question, we decompose into two. One is the Vx direction, so here is C, and this is our x prime, and x prime, y prime. So now the transverse loading, this is Vx prime. Okay, the first one we have to identify the principal axis. So for this case, the y prime will be our neutral axis. Okay, then we deal with the other components. Y prime is in this direction. Okay, so V is in that direction, so here this is our neutral axis. Okay. And now individually, basically tau is from VQ over IT over this case. So for example, tau about the due to Vx prime, and we can calculate tau that is due to Vy prime. So simply we take up the superposition. So in total, our tau will be equal to tau and due to x prime plus tau due to y prime. Okay, we simply decompose into the two directions. And now right now we just simply calculate individual terms here. Okay, that one will be the same as we did, but just carefully determine. So for this case, right now, for example, say, let me pick up, say, again, do the parametric, okay? So say, let me want to calculate what is the shear stress along this side. And for that purpose, let me pick out the shaded area for this. So basically the same thing, and let me pick up the parametric the dimension here. So for example here, in our original dimension we have x, y defined by this. So let me label it. X is from center here. And y is here. So this is our centroid. We want to determine its positions. We want to determine its location, its distance to x prime, y prime individually. And now we're starting from our given information here. So I'm going to mess up the drawing. Okay, so here the distance is y, and the distance from here is 2a. Okay, I copied the information here. So the centroid to here, let me call the y bar. Y bar basically equal to how much? Y plus 2a divided by 2. Okay, y bar. So y bar is from here to here. And the same thing here, we want to calculate x bar. And so for this case, for the point, basically this is our x-axis, right? So basically the x bar equal to 0. The point right away, the centroid right away located on the y, so the x bar equal to 0. Okay. But now our goal is we want to calculate is this one. Yes, the distance to the neutral axis. So actually for this case we are concerned is about this axis, right? So for this one, this we call the y bar now. And for this one, it's the distance to the neutral axis. So basically here I want to calculate is this distance, and that is x prime. Okay. So here our focus for this one should be like this. And how can we do? So the same thing, using the transformation, the old coordinate and the new coordinate. Okay, for the old coordinate is this one. Right now you can see right now our center to the transformed the principal axis is here. We'll look at this map. The center is basically in terms of our new coordinate system. The center is at 3 over 2 over 3a. That is in the y direction, in the x direction, and in the y direction. Sorry. This point has the coordinates in the x directions is minus is a over 6, and in the y directions, we have 2 over 3a. Okay. So for any point, for example, right now we are given a point which has a coordinate. For example, here we are given is this point. We have the coordinate is the x bar, y bar, and that one basically is equal to 0. From our calculation is y plus 2a divided by 2, right? This one is expressed in our original xy coordinate system, right? And right now we want to express this one into the new coordinate systems. So this point, in terms of this, the origins, that is corresponding to is how much? Can I redo this again? It's really confusing. Let me give a label. This origin, the original problem origin at D, okay, and for the new, the principal axis is called the origin is at the C prime. So the xy, if we given in terms of the origin at the D, then we can convert it into the coordinates in terms of the origin at C prime. And for this case, that basically will be equivalent to x minus 6a and y minus 2a over 3. Can you see it? And that is the information we want to take it up. Because right now we're going to convert into the x prime, y prime with new origins. So for this case, right now, because our x prime, y prime in the xy coordinate systems and in terms of the origins at C prime basically is equal to x prime equal to 0 minus a over 6. And then we calculate it there from this one, y plus 2a divided by 2 and minus 2a over 3. Okay, so that is the coordinates we put here. So for the old coordinate system, basically this is.
Wait, are you talking about the point
right now
D
I'm
or
going
the
to,
point C? I mean,
right now I'm talking about is the how to calculate these numbers and this number. So the first step, I need to know what is the coordinate of this point in xy coordinate system, but with the location here.
mm-hmm.
So
With
right now,
respect to that, like, yeah.
yeah. So basically here in
Okay.
terms of this coordinate system, and that is here. Okay. So that one is this one I put into calculation. That will be how much? Let me just write it down. Okay.